Hello, my name is Gordon Kaploff, and I'm here to talk to you about slips, trips, and pitfalls, a life cycle approach to extending ESP run life. A pitfall trap is where one person knows about a trap and another person does not. And often when we see run life graphs that look like this, that in this case goes from 200 to 800 days, sometimes the improvements that are made along the way were actually improvements that were known by another operation before the first ESP was installed in this operation. In other words, the same mistakes made somewhere else were made here. They fell into the same pitfall trap that someone else had already experienced. Now, there are 8 things that influence the run life of the ESP. The reservoir and completion, the application and design, equipment manufacture, installation, operation, monitoring, dismantle, inspection, and failure analysis, and the contract between the ESP company and the operator. 5 of these influence the run life before the ESP is landed, 3 influence the run life during the operation, and 2 after the ESP is pulled and in some cases failed. Putting these all together, it looks like this, and I'm going to make the contract white instead. Now, what do we have at our disposal that will help us in these 5 areas? Well, one document that's available is, or set of documents, is the API 11S series, which has 9 documents referring to ESP operation and run life. If we look at the run life influencers, those set of documents look at 5 of the 8 run life influencers as shown here. But do they go into enough depth? For instance, if we take a look at equipment manufacture, one area that may be of interest is quality. And if we take a look at the API 11S series and search for the word quality as shown here, what you will find is that there are no matches. In other words, the word quality is never mentioned in this document. And that can be very important because if we take a look at a typical run life graph, you can see here there are some short runs. There's a variety of different run lives achieving an average of about 15 or 16 months. By improving the quality of the ESP, we reduce the short runs. And although we cannot change the ultimate run life, we can ensure that most of the ESPs achieve the ultimate run life, and instead of having a run life graph that looks such as this, we have a run life graph that would look like this. Now, if we want to achieve the ultimate run life, or a higher ultimate run life, we need to look at changing other things, not just quality, but looking at the design. We have to look at how the equipment's handled or installed. We have to look then potentially at the operation to get even further increases. So when we take a look at these 8 run life influencers, it could be that we have very competent people operating in each one of these areas. But that doesn't necessarily help us achieve the ultimate run life that we could achieve. Because if someone is doing a good design, but not taking into account the operation, or not taking into account the operations in other parts of the world, they may not achieve the ultimate run life that's possible in a particular field. We need to make sure that everything is taken into account before the ESP is installed. And I am very much looking forward to discussing this topic with you in further detail on April 9th. Thank you very much.